Okay, question 13 has given us an algebraic fraction. Looks, without seeing what the question is, be thinking, when you see questions like this, be thinking what might they want us to do with it. This to me looks like it could turn into a partial fractions question later, or it might even be part A. But that's what you should be thinking about when you see graphs or equations or functions. What might they want me to do with it? Just so that you've kind of got the right path kind of picked out in your head for when they do actually ask you the question. So anyway, it says it goes through the point 3.5 and it's got two vertical asymptotes at 2 and -3. The vertical asymptotes come from these two values here. Vertical asymptotes always happen at values of x that aren't allowed, values of x that aren't possible. So that's what this is asking us about. And this q has to be 4 is because of the vertical asymptote at x equal 2. So for part 1, it's since 2x minus q can't equal 0, or leads to, is probably a better way to say it, leads to a vertical asymptote. That says vertical. And vertical asymptotes occur when the denominator is 0. That's going to happen in this case when x is equal to 2. So if we substitute 2 in for x, we're going to get 2 lots of 2. Take away q needs to equal 0, which is 4 take away q equals 0, so q must be equal to 4. So that's how we've answered part 1. It's probably just a 1 marker. And then we need to kind of use the other point here. We now know that q is 4 to work out p. So we've now got that y is equal to p minus 3x, and we know it's over 2x take 4 times x plus 3. And we know it goes through the point 3.5, and if we substitute that in, we're going to get a half equals p minus 9 for 3 threes over 6 take away 4 is 2 times 3 plus 3 is 6. So we've got a half needs to equal p minus 9 over 12. If I multiply by 12, that gives me 6 here is equal to p minus 9. I don't know why I've written q there, that should be a 9. Get rid of the tail. And if we add the 9 on, that gives us that p is equal to 15, which is what they asked us to show. Okay, part B then gives us the graph of the function now, and they've called the curve C. It says the region R shown in the shaded figure 4 is bounded by the curve, the x-axis, and the equation x equals 3. So that's just telling us this point is 3. We're going to need to know that point so that we can integrate and find the area R, which is what they're asking for. They want it in exact form though, so we need to make sure that we don't use the calculator too much. First job though is to know what this number is. That number is going to be when y is equal to 0. So if we look at this graph, the function, y is going to equal 0 when the top of this fraction equals 0, and 15 minus 3x is going to equal 0 when x is equal to 5. So we know we're integrating between 3 and 5. So we need to integrate, as I've said, between 3 and 5, the 15 minus 3x over 2x take 4x plus 3. However, we cannot integrate that the way it looks. And as I said at the beginning of part A, it's a partial fractions question. We can integrate this if it was split into two partial fractions. That would integrate really nicely, really easily. It would integrate to a ln 2x take 4 over 2 plus, because of the inverse or the coefficient of the x term here, so I'm just applying the kind of the easy version of the reverse chain rule, and this one would just be x plus 3 because the coefficient of x here is 1, so I don't need to divide by anything in this case. So we know that's what we get when we integrate, but we need to work out a and b. So that's what we're aiming to get to between 5 and 3. So my next job now is to work out the a and b so I can substitute those in. So I'm going to kind of take a side step and work out the values of a and b. And then I'll substitute them back into here afterwards. So we've already just said that that's going to split into a over 2x minus 4 and b over x plus 3. If we multiply both sides by the denominator, it's going to cancel for the a term with the 2x minus 4, so we're just going to have a lots of x plus 3. And for the b term, the opposite is going to happen, so it's going to be times by 2x minus 4. And then to solve for a and b, we're going to choose, because this is an identity, should have put an extra line in there, this is true for all values of x. So we can choose any value of x to simplify this down. So if I let x equal negative 3, this is going to disappear and it's going to allow me to work out b. So that's going to be 15 plus 9 is going to equal b lots of minus 6, take away 4 more, so minus 10. So that's going to be that b is equal to negative 24 over 10. Which cancels down to negative 12 over 5. Do the same thing to get the a value by letting this time x equal 2. So when x is equal to 2, we're going to have 15 minus 6, which is going to be 9, is equal to a lots of x plus 3. So that's going to be 2 plus 3, which is 5. So a is 9 over 5. So we've got our values of a and b now. So we can go back up here and swap a for 9 over 5 and b for negative 12 over 5. So that means, I come back to the blue now, that we've got 9 over 10 ln of 2x minus 4 minus 12 over 5 lots of x plus 3, and we're substituting in the values 5 and 3. So if we substitute in the 5, we're going to get 9/10 times the natural log of, what's that going to be, 6. When we sub it into here, we're going to have the natural log of 8, and then we're going to subtract the same when we put 3 in. So 9/10 natural log, when we put 3 in here, we're going to get natural log 2, and when we put it in here, we're going to get 12 over 5 natural log 6. Now, it's great that we've got some logs, but they had in their answer just natural logs of 2 and natural logs of 3. And we've got 6s, 8s and 2s. So how are we going to get 2s, just 2s and 3s? And the trick here is to remember that we've got a rule for logs that says that the natural log of a product is equal to the two values added together. And that's what we can do with this 6. We can split the 6 into 2 times 3. So I'm going to rewrite this as 9/10 of the natural log of 2 times 3, because I can change that then to 9/10 of the natural log of 2 plus 9/10 of the natural log of 3. And that's where the 2s and 3s are going to come from. What we're going to do for this one is we're going to use the other rule, or one of the other rules for logs, which is that the natural log of a to the power of b is equal to b times the natural log of a. And 8 can be written as 2 cubed. So I'm going to have minus 12/5 times the natural log of 2 cubed, and then I can bring this 2 to the front. So that's going to be minus 36/5 times the natural log of 2. So that's where we've got our natural log of 2 from. We've already got our natural log of 2 here, so I don't need to do anything with that. But now I do need to do the 2 times 3 thing for this one again. But be careful, because this is a negative and a negative. So actually this is plus. So I'm going to have plus, where are we looking? Here. Plus the natural log of 12/5, plus 12/5 times the natural log of 2, plus 12/5 times the natural log of 3. So exactly what I've done here, the 2 times 3, I've just done it all in one go. So I had 6, which I've turned into 2 times 3, and then I've split it into the 2 parts. So I had 6, here's my 2 times my 3, and then I've split it. So last job now is to collect up the 2s and the 3s. Let's have a look at what we've got. Does anything cancel? Yes. We've got a 9/10 natural log 2 and a negative 9/10 natural log 2. So that's good. And then we've got a 9/10 natural log 3 plus a 12/5 natural log 3. And 9/10 plus 12/5 is 33/10. So we've got 33/10 for the natural log of 3, and for the natural log 2s I've got negative 36/5 and a plus from this one 12/5, which is negative 24/5, which I didn't really need my calculator for, natural log 2.